cutting out.
Okay.
And I'll let Ms. Richards know as well. Okay. Sophia, can you go up to Ms. Richards' class and let her know to go back to my channel and click Telegraph 2, that file is going to be better. Alright, so we're back. Hopefully this stream will be better for what we're doing. And shouldn't have as many problems here. Okay. Make sure that this is. Jade, where are you? Can you? Let's see. We're gonna have you monitor this stream and see if this stream is working better. Should come up in a little while. Hopefully, and see if it works. Okay. All right. So what we're gonna do today is you're going to have some new materials that you haven't had before. Okay, and those new materials are as follows. You're going to have a long telegraph wire. However, want you to think about, you're going to use this later. For now, I want you to not worry about this. But the new thing that you're going to have is this. Okay? And what I want you to do is to think about what you might use this for to create a telegraph that is going to make sound. Okay, so you've already been able to build an electromagnet. How is this going to help you to create those clicks? Okay, so that's your job, that's your task. So what I'm going to have you do now is I'm going to have my getters come on up and grab all the science materials you had yesterday and start trying to build something that makes noise. I don't know why it's doing that. Yeah, it's problems with the computer network. Find them. They're gotta be over there. Celeste, can you find switches? Celeste, can you find switches? The switches aren't out there. Jade, has it come back up yet?
What does it building your telegraph.
Add a second substitute. Add a second substitute. Okay, so the idea is this. Okay, listen up. Hands on your head. 5, 4, 3, 2, 1. When you are working on this, okay, it should not be 5 different people trying to do 5 different things at the same time. You need to come up with a plan. You need to come up with an idea that you're going to test, and then you're going to work on that. Okay, this shouldn't be, oh, well, I'm going to do this, and then someone goes, well, let's do this, and you're not working on 4 or 5 different ideas at the same time. That doesn't work. You've got to take one idea, try it out. If it doesn't work, then we move on to the next one, and the next one, and the next one. You have to be methodical. You have to have a way of doing things. Right now, when I walk around, I see one person doing one thing, so another person is doing something entirely different. So if I take 2 ideas and merge them together, how do I know which one's right, which one's wrong?
You don't.
You don't. Come up with an idea as a table and say, okay, let's try this. And then try it. If it doesn't work, then you know it doesn't work. Then you drop that idea and you go on to something else. But you have to work as a team, all right? Continue. Well, what did we learn about rapping? You're not taking what you learned. What did we learn about the rapping? Yeah, so why are we rapping it like that then? If you know that that's going to make it weaker. Okay, so whoever rapped it isn't thinking. They're not using what they learned. Right? If you're not going to use what you learned, then don't do it.
Wait, I think this is I have an idea. Using what? We make it into a magnet, and once you turn it on, it attracts a little metal piece. It attracts it, and then when you turn it on, I know, but she's sending it to another place.
So how do I make that really strong? Wrap it as much as you possibly can, but still have some left over so that I can plug it into my turbo. Okay, so I'm going to give you about 4 more minutes to kind of try to come up with something.
Okay, so we don't have a plan. We have 2 things. Let's draw a picture and then this to this. Okay, so like tell us about like right here. Oh, I know. Yeah. But these 2 things have a power.
What do we know about the distance of... Let's think about what we learned. What have I learned about the distance of electromagnetic field to the strength of a temporary magnet? Where is the magnetic field the strongest? No. Where is it the strongest? Where is it the strongest? Where is the magnetic field the strongest? Close to the magnet or far away from the magnet? Close. Okay, so when I wrap it like this, do you think that the magnetic field of this wire sitting on top of all this is actually touching the ribbon? No. So why do I wrap it this way? Got to think about what I've learned. Okay? So if I know that the magnetic field is strongest closest to the magnet, I know that the magnetic field on this wire is strongest where? Close to the wire or this far away from the wire? Right next to the wire. So if I want this magnetic field to go to this ribbon, what do I need to know? It needs to be close. So if I need the wire close to the rivet, I really can't wrap it like this, can I? Right? Now some of it is close, but a lot of that wire is what? It's far away from the rivet. Yeah, far away from the rivet. So very little of the wire's magnetic field is actually affecting the rivet. So how do I fix it? Wrap it around. Take your time. Quality. It's not about speed. It's not about how long it's going to take. It's about saying, okay, you know what? I need the wire as close as possible to the rivet. And I'm going to wrap it like this. Now, how much of this wire's magnetic field is affecting the rivet right now? Okay, now once I get to here, I don't have a choice. I kind of have to go up, don't I? So I start doing a second layer, but this time I can keep wrapping backwards. Okay, now let me ask you a question. Is this wire as close to the rivet as it could possibly be? Yeah, this is about as close as it's going to be. Okay, I can't get any closer. So what I have is two layers, one right on top of the other. Okay, and if I have to maybe start a third layer, I can start a third layer, okay, but not a whole lot because I need to make sure I have room. Okay? Is this wire as close to the rivet as it could possibly be? Yes. Okay? So, you have to think and use what you have learned. Is that wire as close to the rivet as it could possibly be? Or are you wrapping it just to do that? Ladies and gentlemen, time's up. Hands on your heads. 5, 4, 3, 2, 1. Okay, that means no one is touching any science materials anymore. You are now listening. Okay, now as I walk around and I watch some of you working and building stuff, okay, it's pretty obvious to me that you're not using what you've learned. You're just going through the process of doing stuff. Okay, and you're saying, well, I learned that if I wrap the wire around the rivet, I'm going to get an electromagnet. And that's all I need to know. Therefore, I'm going to take my rivet like this. Okay? Therefore, I'm going to take my rivet and I'm just going to wrap the wire around it because that's what I learned. If I wrap it around, I get an electromagnet. So I sit and I do this. And I get something that looks like this. Okay, and I'm sure that if you look around in your classroom right now, you're going to find a lot of rivets that look like this. So all you've done is take your experience and use that experience to do something. Okay? Now, one of the things a gentleman by John Dewey said is he said that learning doesn't come from experience. Okay, you're done. Learning does not come from experience, so switch seats for me. Switch seats with Seth so you can watch from here on out. Learning does not come from experience. Sure, you can have experiences, lots of experiences. That doesn't mean you're going to learn. Right? Where does learning come from then? Okay, a lot of you think, well, if I do the stuff in science, I'm going to learn something. Not really. Okay? Thing that John Dewey said that made a lot of difference. Okay? The one thing that was really important that John Dewey said was, he says, learning comes from reflecting on your experiences. What does it mean to reflect? To look back, to think about your experiences. Okay? Sure, I did this experiment, I played, I wrapped it around, and okay, that's fine. Did you take the time to reflect on it? To think about what it meant? What did that mean? If you don't take the time to think about it, guess what's going to happen? If you don't take the time to think about what it actually meant, and what it means for the future and how it should affect the things I do from here on out, when you don't take the time to reflect, this is what you get. You get this. Okay? Now, if you take the time to reflect and say, what did that mean? When we were looking at electromagnetism and we were trying to break the force and we had the scale and we were putting washers on one side and we were putting spacers in between, and I created my graph, I realized that graph tells me that the magnetic field is strongest where? Where was the magnetic field strongest? Jade? Close. When the magnets are very, very close together, that's where the magnetic field is the strongest, right? Now, what happens the farther I get? The weaker the field. So if I know that there's electromagnetism in this wire, and I reflect and think about what I learned, and I say, wait a minute, so I also know then that the magnetic field on this wire is going to be strongest where? Away from the wire or close to the wire? Close to the wire. The magnetic field is going to be strongest close to the wire. Now, if I want to get that magnetic field around this core, what does that mean for me? That means that if the magnetic field of this wire is not as strong as I get farther away from the wire, that should mean for me that I need to make sure that wire is what? As close as it can possibly be to the core. That's what it means to reflect, to think and say, okay, so what does that mean for me? Okay, well, what that means is that if I do this, okay, so I'm going to wrap it again real quick. Okay, what that means is that if I take that concept and I don't sit and actually think about what that means, and I create a coil that looks like this, and I start to ask a question and I say, is the magnetic field from this wire here, so let me bring it up, is the magnetic field from the top wires of this, what I call a bird's nest, is the wire from the top here, is the magnetic field in this wire actually getting to the rivet? Probably not. Why not? It's too far away from the core. Therefore, I'm wasting that magnetic field. So, I sit there and I think about it and I say, okay, well then how do I make sure that all of the magnetic field of this wire is going to the rivet to make it as strong as possible? It's got to be as close as it can be. Okay? So, how do I make sure that that happens? Well, a lot of it is going to have to do with how you wrap it. Okay, so I'm going to start to wrap, and I want you to start to see the difference. Take a look at that rivet. Okay? I'm going to keep going. Keep going as I wrap this coil around. Okay, you will notice that this isn't about how fast I wrap it. It's about what? How carefully and how neatly I wrap it. Now, once I have one entire layer, I don't have a choice. I have to create a second layer. But that second layer is going to be just as neat as the first layer. Okay, I'm going to continue to wrap. Coming around. And I'm going to make sure that this coil is wrapped around, but it's going to be wrapped around as tightly as it can possibly be and as neatly as it can possibly be. Okay, now towards the end I can put my finger here and then kind of thread it through like I'm threading a needle and pull it tight, and that's going to keep my coil nice and tight. Now compare this to a bird's nest that you saw earlier. Which electromagnet is going to have more strength? This, or the bird's nest? This one. Okay, so if you're trying to build an electromagnet that is going to make a difference, an electromagnet that is actually going to work for what you want it to do, it's not enough just to grab the wire and start wrapping it around. You've got to think about, what did I learn in the previous lessons that are going to help me to make this as strong as possible? Number one, yesterday, do the number of winds make a difference? Yes. So I'm going to use as much of this yellow wire as I can possibly use, because I know it's going to make a difference. The more wraps, the stronger. I also learned that the magnetic field is strongest close to the object that has magnetism. Therefore, I know that this has to be as tight as it could possibly be. When I combine those two ideas, this is the kind of electromagnet I'm left with. Okay? If I don't combine those two ideas, then I'm left with a bird's nest, okay, like I see around some tables right now, that really isn't going to do anything. Then you're not going to be successful. Okay, so continue to work. And here's what I'm going to do. Some of you have already sort of come up with an idea. And we're going to continue this afternoon, but let me go to the desk cam. Okay, take a look at what I have here. So what I've got is I've got a circuit that's sort of being built. Okay, I've got it all hooked up. I can trace the path of electricity and say, all right, the electricity comes out here, through the electromagnet, through the switch, back into the positive side. So this is a complete circuit, except for the fact that right now it is open. The switch is open, therefore I know electricity is not flowing through the circuit, okay, which is good. That way they're not killing their batteries or their cells. Now, the other thing that they did is they put their little steel rivet right here. And so I'm sure the idea is that you guys are going to try to get the electromagnet to connect and pull this rivet. Okay, so here's what I'm going to show you. If you remove this cell here, you're going to notice there is a section here that's got two little bumps. Okay, this might come in useful. Maybe something like this. Okay, so now it would just be a matter of hooking it up and seeing what you can do with it. Okay, so this way you've got a part that's holding your electromagnet. You've got a part here that holds the little metal strip. Now it's just a matter of building a circuit that's going to do what you want it to do. Make sense? All right, so I'm going to give you about 5 more minutes to build. We're going to finish them up this afternoon, so we'll come back together in 5 minutes. Is it working?
Yeah.
Let's see.
Is it close?
Well, it's not going to click if it's doing that. What's it doing right now? Okay, well, you're not going to hold this like this, are you? So why won't it click right now? It's too close. So let's back it up. So let's back it up so that it's not. Now let's test it. There we go. You got something that now is clicking. You can control the sound of it. So make sure you guys understand how this is hooked up and what's actually happening here. Okay, so look at your picture, look at your circuit, and make sure you understand exactly what's happening. Is this metal thing part of the circuit? Is the metal part of the circuit? No, this isn't hooked up to anything. It's just there, and when this gets turned on, it induces the magnetic charge here, and it makes it pull it, right? Okay, what are you doing here?
Maybe it's just surrendering. No, it does not matter. Here, we'll help you. You need help? Everybody's gonna.
You have an idea, but it wasn't controlled.
Can I help you? They don't buy you.
So now, that means if I want it to make noise, is it going to make noise? Too close. If I had it this far, is that going to make noise? Or not? Four is the strongest. Look, so we want it really close. Go on and off. It's moving. So how do I get it to make noise? How do I make it more stronger? What else can I do? Could I bring the lights in? Is it making noise? Okay. How about here? All right, ladies and gentlemen, let's go ahead and stop. Hands on your heads. 5, 4, 3, 2, 1. Is there any team that has a telegraph that is working? Okay, I've got several groups that have got working telegraphs. Sedona, do you guys have one that's working? Not yet? Okay. Serenity, can you bring yours up here? Put it under the table and explain what the circuit looks like and how it works.
Well, what we did was we hooked up our cells negative to positive. So negative, it shoots out of here, and when you turn it on, it's electromagnet. It's supposed to be working. I don't know why it's not working. It was working just a second ago. Maybe someone touched it.
Did not.
Well, it's not working right now.
Okay, so does anyone have one that is working right now? Aubrey, can you get three yours up? Okay, now, eventually your telegraph will stop working sometimes. You got to understand how this works so you can fix it. If you don't understand how your circuit's working, you're not going to be able to fix it. Okay, so can you show us what yours is doing and how it works?
Well, we hooked up the negative to the positive
Okay.
cell, the negative and positive to the cells, and then we hooked up the wire to the negative, and it goes through, and we hooked up the other wire from the core to the
There we go.
switch, and
Okay, so let me hold on. Let me turn you here so people can really see the electromagnet and what's actually happening here. Alright, so here is their electromagnet. Can you hit your switch so they can see what's happening? Okay, so basically what you have is you have an electromagnet that is being turned on and off. What does the electromagnet do to the steel strip? Leah?
it makes it click against it.
Does not make it click against it. What is the electromagnet doing to the steel strip?
Pulling it,
Nope.
attracting it.
Nope. So you're not reflecting on your learning. You're just saying stuff. It's pulling it. And that's not what happens in science. What is it doing?
The core is the energy is going through the rivet, and it's
Is the electricity going through the rivet?
No.
No, it's going through the wire. The electricity is not going through the rivet at all. So, Celeste, what is the electromagnet doing to the steel strip?
It's attracting the iron.
No. What is? I'm asking, what is it doing to the steel strip? It's doing something to it. Thomas, what is it doing to it? Interacting? No. Aubrey?
Inducing?
It is inducing. What is it inducing in the steel strip? Magnetism. The electromagnet is inducing magnetism in the steel strip. It's turning the steel strip into a magnet. And now I've got two magnets, and what are they going to do? They're going to interact. How?
By movement.
By attracting. They're going to attract to each other. And that's why the steel strip is coming. So the electromagnet is not pulling on the steel strip. That's not what it does. What the electromagnet does, it induces magnetism in the strip, which turns the strip into a magnet. And now the two magnets attract. Make sense? That's what you have to understand is happening. Okay, so this idea that, oh, it's pulling it. No, it's not pulling it. That tells me that you don't understand how magnetism works. Magnetism doesn't pull stuff. Magnetism induces magnetism, and then the magnetism between two objects attracts or repels. Okay, so a magnet doesn't pull anything. A magnet induces magnetism in something else, if it's made of iron. Then, once that object becomes magnetic, you now have two magnets interacting, and you have the attraction of one object to the magnet. In this case, you have the attraction of the steel strip to the electromagnet. Okay? Does that make sense when we explain it that way? Okay, by show of hands, how many of you understand that that's what's happening? It's not that the magnet is pulling on the steel strip. The magnets don't pull on anything. Magnets only induce magnetism. Okay, so that's where we are. So for those of you that were not successfully able to build this electromagnet, I'm going to come around and help you guys out, figure out where you were stuck, and we're going to get there. Okay. This afternoon, in fact, I think this might be awesome in reading. If you pull out your science stories, you can read about Samuel Morse, learn a little bit about his Morse code, practice some of that Morse code, and this afternoon we will rebuild the telegraphs and hook them up to each other's so that one group's telegraph is hooked up to another group's telegraphs, and you can actually send messages back and forth to each other. Okay? So that'll be really cool. So that's what we're going to do this afternoon. So if in reading you can read about Samuel Morse, that would be awesome. In the meantime, we are done for today. So let's go ahead and sign off. You can't see yourself, but you're there. All right. So we'll see you, and we'll see you at 2:45.